Hi, everybody. My name is Robert Adams. I'm submitting an entry for the Altair Global Student Contest for November for my shifter mount design. So I'm a part of the University of Michigan BAJA racing team. We are a team of undergraduate students who design, race, test, and build a ATV-style vehicle and compete in the national level every single year. This is my model. It's a shifter, which is basically designed to engage different aspects of our car's drivetrain. It's, as you can see by the red circle, this is its location in our vehicle, and the top right image is what it actually looks like on our frame. For more information about the model, the three plates in green shown at the top right are of 4130 steel that are 65 thou thick, welded together and welded to steel tube. The yellow on the top right is a plate of aluminum 6061, and it is quarter-inch thick. So these steel plates are bolted to the aluminum plate, and the aluminum plate is actually used as a jig to not only weld the steel plates to the frame, but also weld the steel plates to each other. So it keeps everything dimensionally accurate together and in the right location on the car. Aggregate weight is 0.146 kilograms. Steel plates are designed to be laser cut, which means they need to be in a 2D sort of format, and the aluminum plate is designed to be 3-axis CNC machined based on our shop's capability. This will be very important later. So optimization goals must withstand a 95% human male load on top of the assembly. This is the worst case scenario. Say a driver steps on our shifter mount for some reason. Also want minimize deflection and volume-IC stress. Optimize the whole assembly and make sure that the optimization makes the assembly manufacturable. So for parameters, we have rigid supports on the center of the frame tube. We have partition design space for ease of welding, and for separation of the design space. We have extrusions through all design space pieces, normal to each face of the different piece. So there'll be 4 different extrusion planes. And I have a max stiffness target with 20% design volume. Also included extra material for screw threads to ensure that the screws can actually grip into material and the material has not been optimized away. So this is the results for the optimized model. As you can see, this is the sides of the model. They are all optimized with 2D extrusion pattern, and even the quarter-inch thick plate has been optimized with a symmetrical optimization. And you can also see the top here, there's a lot of mass removed. There's still connection to the shifter points here. And it's also optimized with an extrusion, which makes it very easily to manufacture by a laser cutter, which cuts in 2D. Another thing to note is that the material and the aluminum is also able to be clamped so that it can be machined away and there won't be any danger about making sure the part will like fall out of the vise or anything like that because of the partition design spaces. Now you can see the results for the volume-IC stress. It's actually looks like a lot of deflection here, but it's scaled up to a factor of 2,700. So it's actually not really that much if you think about it. The stress shown here is blue, which is actually quite minimal. And for the displacement, you can see this also a big scale factor. The displacement here at the edge is actually welded to the frame, so there's even less displacement than was actually saying. Even for this displacement is nothing, basically next to nothing. The overall weight reduction is 36%, which goes from 0.146 kilograms to 0.0933 kilograms, which is compared, considering the design space, is actually quite a lot. And for room for improvement, try to make the non-design space bigger. So basically reducing the non-design space volume, and improving the extrusion symmetry, making sure that the planes are actually normal to the faces. Maybe trying an more accurate loading scenario where the distributed forces, there's a distributed force pressure instead of an actual point force that's on the whole assembly for a more accurate representation of what's going on. Finally, thank you, Altair. It's been a pleasure, and see you later.